Okay, so today we're going to find the slope of the tangent line, which is just another way of saying slope. And the reason why they call it a tangent line is because whenever you draw a curved surface, and I say, hey, what is the slope of this one point? It's kind of hard to see. But if I represent that by a tangent line, now it's kind of obvious what it is. Okay? The tangent line is a line that touches the curve exactly at one point, and the slope is how much is that line changing. Now the cool thing is that for any curved surface is that the tangent line is always moving and the slope is always changing. So if I draw another point right here, that tangent line would totally be different because it's the line that touches the graph at exactly one point. Now another thing about this tangent line, it's how much the graph is changing at that one point. Now, example here, the rise over run would be something like, let's say 1/3. So the slope here would be 1/3. Would you say that's a fast rate of change or a slow rate of change? I would say it's kind of slow, right? But if I pick a point over here, this tangent line, you can tell it's moving a lot faster. And this rise over run might be something like 1/1. So this slope will be 1. So as we look at tangent lines, it helps us like visually see this is the actual change that's going on. If I look on my right side, it looks like, hey, I'm actually losing value. I might be losing value at, let's say, 1 over, let's say maybe 2, let's say. So it'd be -2/1. And that's a slope here. Now, our problem, as we mentioned before, to find slope, the idea of slope, is I need 2 points. But if I pick another point here, it messes me up. If I pick another point, let's say I pick these 2 points, that slope isn't representative of this point. And this is what we call a secant line. So that's the difference between a tangent and a secant. A secant really isn't the slope of one point. It's a slope of 2 points. But when I'm looking at a graph, I care about where it's changing at that one exact point, at this one exact point. So I can't use 2 points. So that's how we use this equation for us, the limit as h gets closer to 0 of f of x plus h minus f of x all over h. And remember, hopefully you do, that this is a fancy way of saying y2 minus y1 over x2 minus x1. This is just a fancy way of saying it, where this requires 2 points. And this one here requires, actually it doesn't even require a point, but the idea is at 1 point. Okay, why? Because where we would subtract h minus h, that's how far the points are away from each other in the x direction, we call that h instead. And the limit says, hey, where's that h going? That h is disappearing. Those points are literally on top of each other. They are twins. Okay, so we're gonna give ourselves another example. Let's do a polynomial example. If I say y is equal to x squared plus x, and we're going to find the slope of the tangent line at x equals to 1. So we could graph this graph if we wanted to. One fast way, just to say, is x, x plus 1. I'm just factoring it out. We have zeros at 0, x equals to 0, and x equals -1. These are our roots. So these are skills that you learn to graph in pre-calculus and algebra 2. Since we have the roots and -1 and 0. Since this is an x squared and it's positive, We know this is going to be a parabola facing upward. We have some type of a dip here. Now at x equals to 1, we're going to have some type of tangent line that looks like that. Not the most accurate graph, that's fine. Just a point of reference. So we know this graph is going to be increasing pretty quickly, and we know it's going to be a positive slope. So our goal right now is to find what is the slope of this tangent line, the red line. And to do that, let's use our slope equation. The limit as h approaches 0 of f of x plus h minus f of x over h. So this is exactly the same equation we talked about before, because this is the idea of slope. This is my slope. How much is it changing? Okay. So to help you guys out, we're going to write two different equations on the side, f of x plus h, and then f of x. So we know f of x is already x squared plus x. I'm just writing this out so you guys can kind of get the bearings of it still. And the new version, the upgraded version, every time I see an x, I'm going to write x plus h instead. So if you look here, I just wrote parentheses so I can fill out those parentheses later. Some kids really need to write it separately because it doesn't click, but it's fine. So I'm going to write x plus h, x plus h. Every time I see an x, I'm going to write an x plus h instead. Okay. So we rewrite the equation, the limit as h goes to 0 of copying x plus h squared plus x plus h. So, oops, I always make the mistake. I always write a plus sometimes. And that's gonna mess me up. So minus x plus h. Whoops, sorry, that was the first one. Minus parentheses x plus h. Whoops, darn it, I'm sorry. I'm just copying in my brain. I'm copying the wrong thing. Okay, there you go. This is my new minus old. Take a look at that. New minus old, all divided by h. Now, why can't we plug in h is 0 right now? If I plug in h is 0 right now, I want you guys to all get this in your head. If I could, I would. If I could take my kids to Disneyland right now, I would. Okay, I wouldn't. But see that? It's h is 0, h is 0. If I made them 0 right now, wouldn't this be wouldn't this be x squared plus x? And wouldn't this subtract this become 0? And we would plug in 0, h is 0, 0 over 0. This would be totally useless to me. Why? Because we're subtracting our x's and y's as if they were 1 point. Imagine if I told you this point was, if I plug in 1, it's 1 comma 2. That's what this point is, 1 comma 2. So what if I said find the slope saying 2 minus 2 over 1 minus 1, right? That's my y, and that's my x, and that's my x. This would be 0 over 0. It'd be ridiculous. You can't find the slope using 1 point. But calculus and limits allow us to do that. So we learn by our rules. Instead of trying to plug it in, we're going to instead multiply it out and try to divide h. So we end up with 0 over 0. So we know this is indeterminate. It's always going to end up indeterminate in these cases. So let's go ahead and keep going. I want to multiply out the binomial. So hopefully you guys can do this a lot faster. So if I square the binomial, that's x squared plus 2xh plus h squared. Square the front, square the back, and double that middle. Plus x plus h minus x squared minus x all over h. Looks like a lot of characters in play. But we can always be guaranteed that stuff will cancel out. So I see x squared, I see an x, and x. And if you do this right, please look at all the remaining players. The only remaining players we have left are all players with an h in it. you have an H, you have an H, you have an H. So if you do this correctly, there should only be players with an H left in it. So limit as H goes to 0. I'm going to skip a step by factoring out the H because we all had an H. And this is where our hole is. Whenever you have 0 over 0, you have H over H because that was the 0. And here we go. Limit as H goes to 0. We're going to divide those together. We have 2x plus H plus 1. We can now freely plug in H without being offended. Limit H, whoops, sorry. So once you plug it in, remember we don't write the limit. It's 2x plus 1. Now, what does 2x plus 1 represent? It represents all the possible slopes for this whole graph. So the slope equation for, let's say y, is m is equal to 2x plus 1. That's our algebra 1 understanding of it, right? M is our slope. So our slope for this whole graph is mx plus 1. Well, we asked ourselves, what is the slope when x equals to 1? So we can go back now and say, well, I know that x is 1. Let's go ahead and plug in 1. So the slope m at x equals to 1 is 2, 1 plus 1. M is equal to 3. That is the slope at 1. Okay. Now, the follow-up question to this would be, write the tangent line equation. So once we have the slope, we can write the tangent line equation. Now, my suggestion for you is to use this form, not y equals mx plus b, but I recommend point slope form. Because you are given the slope and we discovered what the point was. To look back here, we said our point was going to be for this graph. When x is 1, y was going to be 2. Okay, how did I do that? Our graph was y is equal to x squared plus 1, sorry, plus x. If x equal to 1, plug it in, y is equal to 1 squared plus 1. That gives me 2. So y is 2. So that was my x and y point. We have our slope, 3, when x is exactly 1. So let's fill out our point slope. Point slope goes y minus y1 equals to m, x minus x1. The other form, again, was called slope-intercept. So slope-intercept form was y equals to mx plus b. And in this case, we need to make sure we have an m and a b. We don't have b. Okay, so we're not going to use that form. Let's go ahead and finish this. Plugging in our y and x. We said x was 1, y is 2. So we're going to say y minus 2 is equal to x minus 1. And m, we have m over here on the right, is the number 3. So we can stop here. Oops. We can stop here because this is the equation of the tangent line. So on the calculus test, you want to make sure you read the question and don't do any extra work if you don't have to. This is an equation, and this equation represents the tangent line. If you want to keep on going, you could write to slope-intercept form. And we can multiply that. We can multiply the 3. Y minus 2 equals to 3x minus 3 plus 2 plus 2. Y equals to 3x minus 1. So I want you guys to reflect on what this line equation represents. This is the tangent line at point 1, 2. Now, does this tangent line fit the characteristics that we said? Is the slope 3? Yes, it's 3. Does this tangent line go through point 1, 2? If I plug in 1 here, 3 minus 1 is 2. Yeah, it goes to that point. And if I go back to look at my graph of my crappy estimate of my tangent line, yeah, that's not bad, right? That would have gone through -1. Woo, that was close. But what happens is this tangent line will change as I pick different points. As I pick different points, the tangent line will continue to move. And we'll have to come up with new equations for every point along that graph. You can almost think of this like the stock market. When you look at the stock market, you see the graphs of the stock market doing this. It starts off the day and goes up and down again. That's my life. Okay. So when the stock is going up, that means you have a tangent line that's pointing upward. That means you're making money. You want to see that. When you're losing money, that's your tangent line. When you lose a lot of money, you want to know that. When you can see it actually slows down and tapers off, maybe it'll increase. Now, here's something kind of interesting. The stock market, I'm going to pause this, actually, so I don't have to get in trouble. So on Excel, you're going to do two things. The first Excel is for you guys to calculate what is the slope at a point, okay? So what is the slope at a point? So stuff like that, stuff like this, okay? You're going to do stuff like this up here. Use the limit. The second part is to write that tangent line equation. So you're going to plug in the values of your x and y right here, and then you're going to give the slope intercept, okay, or however they ask it. Okay, let's do another problem. Let's do a square root problem as we practice these. So y is equal to the square root of, let's do x plus 1. Okay, x plus 1 at 3, 2. Or you could say x equals to 3. Wait, yeah, that's right. Plug in 3, 3 plus 1 is 4, square root of 4 is 2. Okay. So let's find the slope. To find the tangent line, we need to find the slope. So sometimes they'll preface the question by just saying find the tangent line. Well, to find the tangent line, we need these parts. We need an x and y and the slope. And by looking at this equation, we don't have either. I could plug in the 3, y kicks out the 2. We do have the x and y now, but we're still missing the slope. So the thing about calculus is that we have to come up with that ourselves. They'll ask us this general equation, and we have to come up with the equation and the parts to answer that. Okay, so let's come up with the slope. The strategy for slope here is we're going to use the limit. Limit as h approaches 0 of f of x plus h minus f of x all over h. You might get tired of writing that. Fine, don't care. Let's write our f of x version and then our f of x plus h version. F of x is just square root of x plus 1. And the x plus h version is my upgraded x plus h plus 1. You can write that without the parentheses if you want. You can write this as square root of x plus h plus 1 if you want. Doesn't matter. Okay, let's go ahead and set this up. I'll give you guys 10 seconds to set this up yourself if you haven't done so already. Go ahead and set up that limit for me. Okay, hopefully you're plugging it in. Just straight copying. So our strategy to deal with square roots is multiply by the, what? Do you remember? Sounds like a disease. The conjugate. Okay, sorry, just me. So one thing I need to remind you, just to talk about this, if you plug in h here, you would have ended up with x plus 1, x plus 1, right? And that would have canceled out. That would have given us our 0. Because the point of us doing slopes this way is that we are finding the slope of not 2 points, but 1 point, as those 2 points become 1 point. Sounds like a song. The limit as h, oops. So here we're going to save time, just multiply it by the conjugate. Remember what the conjugate is? It's the plus version. So square root plus square root over square root plus square root. If it was plus, we would do the minus. Okay, x plus h plus 1, and x plus 1, x plus h plus 1, x plus 1. We worked this out before. We're just going to go ahead and skip to the end. So it'll be, I'm going to write that. X plus h plus 1 minus x plus 1 all over h. And we have a square root plus a square root. The reason why we do the conjugate, because it gets rid of all the square roots on top. Now that I got rid of all the square roots on top, we have some like terms that you guys can see are going to cancel each other out, the x's and the 1's. And we're left with the limit h goes to 0 of h over h in square root of x plus h plus 1 plus square root of x plus 1. The h's divide out like we were hoping for. That was our 0 over 0. We're at this step. We can now freely plug in the h, and we will not end up with 0 over 0. Oops, I'm going to plug it in now. Oh, I'm writing it. Remember, you don't write the limit when you plug it in. Hey, look, they're twins. So we have 2 of these. So again, what does this represent? This is not the tangent line equation. This is not it. Go find it someplace else. But this is our slope. And it's our slope for all of y at x. You can plug in x wherever you want. So m is equal to 1 over 2 square root of x plus 1. Now I'm going to show you guys this new notation. This new notation means a derivative. It's going to be y and put a little line next to it. And look, it looks like a tangent line. It looks like a tangent line. And another way you can say it looks like slope. It looks like a slope. This is y's slope. Think of it as y's slope. Y's little buddy. Now, we said we want to find the slope at, back here, we said it was 3, 2. So the slope at x equals to 3. All I need to do is plug in 3 to make this equation work. M is equal to 1 over 2 square root of 3 plus 1, which is 1 over 2 square root of 4. We know what the square root of 4 is, just 2. The slope is 1 over 4. Now, why calculus can be kind of hard is because there's a lot of steps. Actually, the math part is really just algebra 2. Any teacher will tell you the math in calculus is just really algebra 2. The hard part is determining what to do. What is the plan? Our question was, find the tangent line. And we have to go through all these steps here to find out the parts so we can finish our plan. Our plan is the tangent line is y minus y2, so whoops, y1 is equal to m x minus x1. That is my equation of a line. And if I plug in the parts of the tangent, I have the tangent line. Y minus, we said the point was at 3, 2, I think. Looking back up here, yes, that was 3, 2. That's my x and y. 3, 2. Whoops, yep, 3, 2. Wait, whoops. Well, 2, 3 or 3, 2, right? 3, 2, yes, 3, 2. So is equal to 1 over 4, which was my slope at 3, and x minus 3. We can solve this for y if you want. Y minus 2 is equal to 1 over 4, x minus 3 over 4. And when I add 2, I'm going to actually add plus 8 over 4 plus 8 over 4. Because in my brain, I like actually writing the common denominator over. So y is equal to 1 over 4x plus 5 over 4. That is your tangent line. See, that's a line equation. This is a line equation. And it gives me the slope and at point 3, 2. Okay, sorry about that. I didn't record it. But just to recap real quick, we're doing a fraction problem at 1, 1. We are writing the tangent line. So we wrote our points slope form. We're taking the tangent slope by doing the limit equation. And we're gonna just about to plug it in. So here's our versions. 1 over x plus h squared minus 1 over x squared all over h. We just copy those parts in. Now the hard part now is how do I get rid of those fractions? How do I get rid of those terrible fractions? And our rule was multiply by the common denominator. So we're going to say common denominator is I need an x plus h and an x squared. I need both these terms, x plus h and an x squared to top and bottom. So very similar to our radicals where it became all crazy. Same thing right now. Okay. So here's the general idea. If I multiply this to the front fraction, the x plus h squared and x plus h squared both cancel out, leaving me just, a x squared. So we rewrite that limit, h goes to 0, of x squared on top front. Ooh, that looks so much easier, that fraction. When I distribute to the back, what cancels out? What divides out? Well, the x squared divides out, leaving me a x plus h squared. So we took that crazy top fraction there, what I call sometimes the Tower of Terror, just craziness on top, and we got rid of the fractions. And you move them to the bottom. Because when I multiply these over, we're just left with x plus h squared, x squared. To combine the upper right corner here, since that's a parentheses squared, you have to multiply that out to make this work. So the limit, h goes to 0. We have x squared minus x squared plus 2. Oops, I need to distribute the negative sign. Negative 2x h plus, did it again, minus h squared. So why is it negative? Because I distributed this negative sign. Okay, make sure I copied everything correctly. And we said h, I want to move this around, x plus h squared. Okay. Now you'll see some like terms, x squared, x squared. Remember I told you the rule, whatever you have left over needs to have an h left over. Yep. Everyone has their backstage passes. You guys all have the h. Because you need to divide that h afterwards. And that's our goal. That was our 0 over 0. Writing on back to the left, limit, h goes to 0. We have, I'm going to copy the h out so you can see it. Actually, I'm going to copy a negative sign. Negative h, and we're left with 2x plus 1, plus h over h, x squared, x plus h.
Is that a 1 or an h?
That's an h. Because it was h squared. So now we see that the h's can divide out. Limit h goes to 0 of negative 2x plus h over x squared, x plus h squared. So just as a reminder, I need to keep reminding this, that if I plugged in the limit 0 over 0, we would have died there. It wouldn't have worked. But after we divide the h, hey, there is no 0 over 0 anymore. That's gone. So we can plug in freely. Let's go and plug in 0, plug in 0, and we're left with negative 2x over x squared, which becomes negative 2x over x to the 4th, which is negative 2 over x cubed. Now, this is our slope equation. So you can say m, in essence from algebra 1, slope is x cubed. And at our point, and our point was 1, 1, m is, plugging in 1, is negative 2. So now we can write the equation y minus y1 equals to m. Oops. M, x minus x1. We have our point, x and y, which is 1 and 1, 1 minus 1, x minus 1. Our m is negative 2. And this line is the line of the tangent. If you want, you can multiply it out and simplify it. Y minus 1 equals to negative 2x plus 2 plus 1 plus 1. Y is equal to negative 2x plus 3.